over there. All right, so we're talking about Terraform. And as I mentioned before, my entire team has been working on Terraform for the last month. And me coming from Microsoft before I was at Aiven, I actually had experience with infrastructure as code, but not with Terraform as itself. One of the things that I would often bump into is at conferences, we would talk about this thing like Azure Developer, it was like the Azure Developer CLI. And like the Azure Developer CLI, it's great because it allows you to quickly spin up and tear down resources really quickly. And you have to use Bicep. And people would go, but I want to use Terraform. And I was like, why? Why would you want to use Terraform? Terraform's scary. Don't use Terraform, use Bicep. Bicep is also scary, but like it's less scary. Which we eventually were just like, no, we actually support Terraform too. You can use Terraform. Terraform works. That being said, at Aiven, I don't have the privilege of having a company that has hundreds of thousands of people and can build their own like infrastructure as code language. So instead, we just support Terraform, which kind of gave me the opening to dive into this. Now, I've already said it once, but Terraform is this thing that's called infrastructure as code. Now, infrastructure as code, and some of the biggest examples that you'll see in infrastructure as code is, as I mentioned before, Bicep, which is like a Azure resource management language, and Pulumi, which Pulumi is a really interesting topic, and I would love for someone else to give a talk about that one day, because it's actually infrastructure as code in your preferred language. So it's taking some of the Terraformisms that we have here and making it so that you don't have to write Terraform, you can just write Python, or you can write JavaScript or Golang or whatever language you want. Our company does have a Pulumi provider as well, but we don't talk about it that much. I don't know why. We're going to talk about the Terraform thing. Also, I do think that Terraform in itself is, everything is kind of built around like what kind of Terraform looks like, which is YAML. If we're being honest, it's just YAML. It's very, very organized YAML. Everything is YAML all the way down. You'll start to look at it when I show some code examples. It's very much it's a syntax language. It's very syntax heavy. We're not diving nearly as deep into like all of the capabilities. We're talking about the capabilities that would allow you to quickly spin up your infrastructure. And that's why I talk about infrastructure as code. Quick show of hands in the chat. How many people here have a web app that they deploy on some type of service, whether it's AWS, Azure, GCP, whether it's, let's go like fly.io, let's go DigitalOcean, Vercel. I don't know if Vercel does Terraform, but that's an interesting idea. Okay, how many of those people have also had to spin up a resource more than one time? I'm just wondering, because this is where we start thinking about like how Terraform can be super beneficial. How many people had to go back and like go through the notes of how they set the thing up and then struggled to be like, how do I, like, what do I set this value as? And do I check this button? Like, how many people have had to deal with that part of the configuration and just can kind of commiserate with me with how much a nightmare is when you are trying to build something and you're like, I missed a box. I didn't check a box somewhere, and now my site doesn't work as I thought it was going to, and something's broken, and I'm a failure. Like this is, I dive deep into like self-deprecation really quickly when it comes time to build out my infrastructure. So as hands are being raised here, this is kind of the solution that Terraform was created to solve. Terraform is this way that you write that configuration one time. And if you plan accordingly, you only have to write that configuration one time. And from there, you can make some smaller minor adjustments that you need to, and trust that your configuration is actually like stable. There are also some nice features in Terraform that allow you to see what's going to happen before you actually apply those changes, which is good. Like, especially if you can, like, you get into the habit of doing that. And we'll talk about that a little bit later. You can definitely come in and look at like a Terraform plan and say, okay, this is going here. This creates this thing. Oh, wait a minute. I don't see that one piece that I'm relying on. I need to go back and I need to check my Terraform code, or I need to check my configuration and make sure that I did it exactly the way that I was supposed to. That's the plan. That's like the big thing that Terraform and infrastructure as code in its entirety is meant to serve. I'm sorry for your retinas. I didn't design the color scheme for OpenTofu. Terraform is actually no longer an open source project. I think it's a source open project, which means that you can see some of the code base, but it is the property of HashiCorp, which is now the property of IBM. For some people, that's a problem. Luckily, OpenTofu is around. And OpenTofu is fully open source. It's ran by a community of individuals. It's not tied to any particular company. If you don't want to, or you have some requirements that prevent you from using Terraform, and I should still say, like, you can use Terraform absolutely free. You don't have to pay HashiCorp to use Terraform or any of that stuff. But if you are partial to using open source tooling, or you have to use open source tooling, there are some questions around like actual licensing when you go to do certain things. If you want to incorporate Terraform into a product that you're using and you need it to be open source in order to do that, take a look at OpenTofu. The only difference at the moment, obviously over time things will start to splinter. OpenTofu's been around for a year. They've had a few different versions. I think they're on 1.9 at the moment. They just released an update earlier this week, or last week, I believe. I think it was the 25th that I was looking at. The only difference that you'll have is, instead of writing Terraform, whatever your command is, you just write tofu. And OpenTofu also has access to the Terraform registry. It has access to all of the different services and modules and providers that were built initially for the Terraform ecosystem. All right, so you're going to hear the words Aiven a lot in this. I work at Aiven. I am the staff developer advocate at Aiven. I'm also the team lead for our DevRel, our developer relations team at Aiven. I am going to be using Aiven's Terraform provider for this. The biggest reason is, again, I've been playing with it for a month, so I kind of have some familiarity around it. The nice thing about Aiven is we have all these different platforms. We're not really going to be talking about any of these platforms from a what they do case, but the best part is our Aiven provider for Terraform has resources devoted to all of those individual tools. And this is why Terraform for us is great. Aiven's big use case is allowing developers to have all of their different database services under one platform. So whether you have a Kafka instance, a Postgres instance, MySQL, Google's Alloy, AlloyDB Omni, Grafana, ClickHouse, any of those, and you need to have them all talk together, you get a single unified platform to do that. You also get encryption of your data at rest and in transit. And we integrate with several other third-party tools, and all of those things we support with our Terraform provider. So again, yes, we're going to be talking about some of the things that I do in my day job. There's reasons, there's methods to the madness, but also this is great because you can see how these tools work together in their own, in a cohesive system. Now, if you want to utilize Terraform for something like Oracle's OCI, Microsoft Azure, GCP, AWS, you want to use it to deploy things like Kubernetes, Alibaba Cloud, you can do this as well. I think it's a tip later on in here, but the Terraform registry, the way that their documentation is set up is actually really, really powerful because you have to expose all of the endpoints in your code through the documentation. I think it's auto-generated just in how consistently it's built out. And it's a really nice feature that I've loved is that the documentation, I've gone through AWS's documentation. It's a problem. Let's be real. It's not great. Google's a little bit better, but also, sorry. Azure, we won't even talk about. I helped write some of that documentation. I know the state of that one. But the Terraform registry, you don't have to read a different style of documentation for all of these. It's one style of documentation across the board for all of the providers because it's generated based off of the information that's in Terraform. So, what are we going to talk about? We've got plenty of topics here. File organization, setting up our Terraform instance and connecting to a provider. We're going to add some resources. We're going to see what running IAC looks like. I might jump back and forth between our actual like Terraform project that I have. But I'm going to try to stay in the slides as much as possible just to keep people on the same page. If I need to strengthen that up with a little bit of an example, we'll do so. We'll talk a little bit more in depth about some resources, and then we'll look at some of the other pieces of Terraform that make it as powerful as I'm saying it is, and also how not as scary as it is. I think if you look at Terraform sight unseen for the first time, it's a little intimidating, but once you know what is happening, then you're off to the races and you're good to go. And we're going to talk about modules. Modules are a thing that I literally started working on yesterday as I was preparing these slides because I wanted to make it easier for me to run stuff. And now we have like an entire plan at work to modularize a lot of the work that we've been putting in. So yes, modules are a thing that I can speak to, but it's going to be like the very, very last bit, and we're only going to cover the kind of the top layers of it. You'll also see these slides that are called tips. These are my personal tips. These aren't like anything in particular, like, oh, this blog post said to do this. This is just a thing that as I've been building things out, this is how it's been easier for me. Take them with that knowledge. Again, you're not talking to a Terraform expert. You're talking to a person who is deployed. I've probably had to run Terraform apply about 100 times in the last month. So I've been doing this a lot and focusing on it pretty deeply. So I'm hoping that these tips will be beneficial to those who see them. And with that, let's jump into the first thing that we'll see, and that's file organization. So Terraform's file organization is actually relatively loose. Really, you only have to have one .tf file. I call mine Aiven.tf. That's like the base file, but all of these files that you see here are individual resources that pull from a provider, and we will talk about what that means in just a second. And then some other tools that support what's happened. But in reality, if you're doing something relatively simple, you can have a singular Terraform file. You can call it whatever you want as long as it's something .tf. Now, I do it this way because I'm often working with multiple resources, and it's easier for me than to open up one file and then try to scroll down or search or hunt and peck for which resource that I'm looking for in that singular file, especially when some resources are 5 lines of code, and other resources can be like 50 lines of code. It's really hard to kind of get your bearings around all those areas. So I like to put all of my separate resources in their own file. The thing is, you don't actually have to do a lot of like stapling. Like, we're in a Python, group here. There isn't really this concept in terms of your Terraform structure of like a import this from this. There is, but you only do it in one file. And then at that point, you can reference that point in any other file in that directory. We also will have some variables. Again, we'll talk about what that means a little bit later. But the first tip that we're talking about here is that Terraform that's written at the top there is actually the directory. As you can see, there's a bunch of files here. Terraform wants to be called, the Terraform command wants to be called inside of the directory that your Terraform files are in. So you've got 2 options there. There's like this -ch dir equals and then whatever your folder name is that you can do, or you can just cd into that folder and run your commands. I didn't talk about this before, but like, how do you install Terraform? It's 2025. Like, if you go to the Terraform website, installing it is the easiest thing that you'll do. If you're on a Mac, you'll use something like Brew. If you're on a Linux or Unix-based device, you'll use apt or yum or whatever your package manager is of choice. If you're on Windows, you'll use WSL, and then you'll use whatever your Linux system would. I think that's apt at that point. I'm sure you can do things like Chocolatey, or you can just go and download a package and install it, and then it's there. But installing Terraform is easy, and once you have that, you'll have what's called it's just the Terraform command at your fingertips that you can just type in your terminal. So yeah, I called this folder Terraform. Another common folder name that I hear is infra. That's, obviously infrastructure is code, so all your infra goes in the infra folder. That's ultimately up to you what you want to call it. I would just say consistency is key, and maybe your company has a style guide in which how they want things named. Our company actually they call it Terraform, so that's why I called it Terraform. So setup, this is like the initial setup. As I mentioned before, really you have that one main file. That one main file for me is that Aiven.tf. Now, Aiven.tf, I kind of mentioned before, there is like the one time you need to do like this import type thing. And that's when you're defining your Terraform spec. So you say, hey, Terraform, my required version is greater than 1.0. That is actually optional. You don't have to put that in. I would advise you put it in just so that, like, hey, if you're using an older version of Terraform, it's not going to let you do it. And then you're going to have this list of required providers. For me, I said, obviously, it's the Aiven provider. That's pulled from the registry. Anytime you just see like, some org/provider name, that's going to automatically assume that it's pulled from the HashiCorp registry, the HashiCorp Terraform registry by default. You could point to a different source if you have a provider that you have in GitHub or stored anywhere else. You can link directly to it. We'll talk a little bit more about that when we talk about modules, but from there, we also include things like versions, just like with Python. And like when you import something at a particular version. So over time, you may have, obviously they're going to keep updating and updating and updating. When we get to like Aiven, Terraform provider 5.0, we probably don't want to go there without seeing why we needed to do a major version change. That might introduce some breaking changes. So what we're doing is basically like when we add version settings to our imports in like a requirements.txt or like a pyproject.toml, we're saying, I only want the Aiven provider and make sure it is within version 4.0 or higher, but not 5.0. That way, if some major update came out and it wants to update to that major version, I can at least stop and check and go, all right, cool. This looks fine. Let's keep moving. Then from there, you're able to reference that provider in Terraform code. So from here, you can see I need to set my API token for the Aiven platform. So I do that by saying, hey, provider Aiven, my API token equals this variable that I have called Aiven API token. I'm not going to tell you what that token is because it's really long, character string, does much stuff. And then from there, I'm going to say, you know what? Instead of setting data, I just want to get data. So then I can use the data command to say, hey, Aiven provider, using the API token that I've set, I'm going to create this title called button app. And inside of that, I want you to tell me what the project name is. And the way that Aiven works is you have sets of projects and you define what that project is by default. So it's going to look at my API token. It's going to retrieve my account information. It's going to look at whatever my default project is. And it's going to say, all right, bet your project is that default project name. So now, anytime we're referring to creating a new resource, it'll ask for the project, and I don't have to sit there and type the name out every single time. I can just say, use the default project name, and that default project name is found at, and you'll see this in just a second, but the way that you reference these is you take the name, you can see my mouse here, you take the name that's here, and everywhere you see a break, like a page break or some quotations, just add a period. So Aiven.aivenproject.button app, and then we would have dot project. And that would reference this value here, this Aiven project name. Sometimes it's faster to do it that way. Sometimes it's not. It's good to do it this way because what that does is that creates consistency across your entire application, which is what we're really looking for. And as I mentioned before, with that provider, that import kind of stance here, what we're doing is we're just saying Aiven, source Aiven, version, so and so. I could probably delete this slide, honestly. Oh, well, I just talked through all that. Nice. All right. So we've set up our initial provider, which is great. So now we want to start adding resources and we want to test and run our infrastructure as code. We want to actually test and apply our Terraform. So as I mentioned before, in that tree of items, I like to put all of my resources in their own file just so that we can see what they look like separately. And the way that we actually create these resources, and you'll kind of learn what the language is around these. So we've talked about a provider. A provider is not a module because that is a whole thing. A provider is this overarching suite that hosts resources that correspond to code execution from whatever the provider is. So your provider is saying, here is the list of commands that are available that when executed will implement something within the Aiven space. Same thing if you use the AWS provider, it would execute commands within the AWS space, GCP, etc. So from here, we create a resource. A resource is like an area of that provider. So this one's called Aiven Kafka. So this would create a Kafka service within the Aiven resource. Next, we give our Aiven Kafka instance a name. We're going to call it Kafka Button App, which you're going to see the words button app a lot here. The workshop that we just did was measuring user interaction through Kafka using an app that we called the button app, which is, if you remember how Reddit a few years ago had this thing about keeping the button alive, it was something similar to that, except for it was a web app that was basically saying, hey, how many times will users click this button if we continue to goad them into pressing it? It's fun. I can share that with you at a different time. It is on the internet. It is live. And it is still very much a work in progress. So you're going to see button app a lot here. This is the actual Terraform code that we use to build that button app, and that other people could use to build the same button app, but in their own resources. All right, moving on. So again, we talk about our project. As you can see, we define that project. Like I said before in that other page, everywhere where you saw a space or quotations, we added a period, data, Aiven project, button app, which is the name of the project, and then the project value. And then we have our service name here. This is the Kafka button app. And then we did this random string suffix here. Now, we haven't talked about this, and we're actually not going to talk about it, mostly because of time. But just looking at what I had said earlier about how you can read what's going on through looking at where the periods are, we can quickly kind of interpret what's happening here. Random string is a provider. It's a provider that's given to us by HashiCorp. And what it does is it exposes a bunch of functions that we can use to generate random characters. So we can say random string. We created a random string called suffix, just like here we created an Aiven project called button app. And then what we're going to do is we want the result of our suffix random string. Now, in that code, what it does is it creates a 6-character suffix that we're going to add to each of our services. That way we can quickly identify what services belong to what project. It also means that we can have multiple versions of the app running at one time, and we don't accidentally delete like the wrong service for an app because you have, 5 versions of Kafka running that all look the same because they were all instrumented the same. They'll each have their own unique suffix, and we can look at that and go, okay, all of app ABC123 has the suffix ABC123. We could also use something like this to create a tag. We often do this with tagging, to where we can then say, give me all the lists that have the tag ABC123 on it, and then delete those services that way. This is a great way to separate that out. That would also keep us from overwriting a resource that we've already created, yes. And that was actually the reason why we added it, because we kept overwriting each other. We kept noticing that all of our topics were resetting when someone would create a new build, and it was because their local builds were overriding our quote-unquote production resource, which is a big no-no, and that's why random naming is top-notch there. Again, we have what's called a variable. We will talk about variables in just a little bit, but we have a variable called cloud name. For Aiven supports all the clouds, so this is going to be something like Google US East 1 if it's me, but my team is based out of Europe. So for them, they might set their variable to AWS Europe West 1 or something for like London, or West 2 for London, I think it is, or Google for London. And this is also great because, again, if you're running multiple versions of this app, you can say, hey, it might be cheaper, or we might have a deal that we can run all of our test stuff, or it might just be policy to run all of our test stuff in AWS, and then all of our production stuff lives in GCP land, or our test environment or our test cloud is in like New Zealand away from everybody else, and it's a little bit slower, but that's fine because it's cheaper. It's not really cheaper. It's actually more expensive to do that. But then our production regions are these 4 regions. So we do that. This is a great way to set the variable once and make sure that all your resources spin up in the correct place. And it helps reduce your opportunity for mistakes. And then the plan for us is business 4. That's something that's particular to Aiven. We have different plan sizes, which allocate different amounts of resources. But the thing that you'll see is across all of our services, a lot of this information is similar or the same. I talked about this. I talked about not wanting to show a lot of code, and I'm going to immediately, can y'all see a terminal here? I just want to make sure that y'all can see this terminal before y'all can't see the terminal. Okay. Nope, y'all still see slides. Let me see if it'll change. Add windows. I tried to share that. I'm going to share the entire screen. See if that helps. Okay, now can you see a terminal window? Yeah, there we go. All right. All right, so here's my terminal window. If I'm going to do, I'm in the over here. I'm in, okay, cool. You're going to have to ignore the fact that some of this stuff is now in modules because I did this yesterday in preparation for this. So we're going to CD into modules, and we're going to look at all of those resources there. And I can make this bigger if I need to make it bigger. You know what? If I have to ask, I should probably. My terminal is, I'm going the wrong way. My terminal is ghosty. And yep, I'm just making it worse now. So I'm going to stop because let's do, can I? Yeah, I'm just gonna stop on that one. All right, so if I look at Kafka, right? If I look at Kafka Terraform, we see at the very top here, I'm pointing and y'all like can't see what my fingers are doing, but I'm highlighting this area here, which is Aiven Kafka, Kafka button app, and here's that information that we had at the very top. Ignore the rest of this because we're gonna come into that in just a second. If I were to go over and then look at my ClickHouse.Terraform, you're going to see the same stuff at the top. And that's what's important because of that, we can set that value one time and we don't have to set it for each one. We can say, hey, I want all this stuff that's going to be used across the board. I want that set once, and I want you to do the same thing for all of these resources. Same if I go to my PostgreSTF, same thing. There are going to be some differences, but the nice part of this is that a lot of that basic configuration never changes. It stays the same, which is just loving it. Absolutely loving it. Let me go back to my slides. All right. Y'all can see slides. Y'all can see slides. Perfect. Again, and we're going to talk a little bit more about variables and how to set up variables in the long run, but I want y'all to just kind of get the feeling of, I want y'all to buy into this. So far, we're still tracking. Everything's still great. I talked about this a little bit earlier, this tip of like, if you don't know what resources are available, I can actually just show you. No, I can't. Yes, I can. Yes, I can. I'm going to ignore my messy stuff and the spicy peppers here. Let's go into the Terraform docs. These are the Terraform docs for AWS CC. I don't know what AWS CC is. I was wanting to verify what I was about to tell you. But on this side, you're going to see guides, you're going to see resources, and then you should see data, but they must not have data. If I go Aiven, cool. And I go into their documentation, we see the same thing, guides, resources, and you see all the resources that are available to you. And we could keep scrolling and you see all the data sources that are available to you. They should be about the same. And then when you actually look here, you're going to see things like example usages. You're going to see like authentication. But what's more important is when you go into a resource, let's just go into Aiven account. Let's go to something that's not deprecated. Aiven ClickHouse. Cool. You see this quick example at the top, which is great. And then you see this schema. The schema itself it's telling you what it's called, it's telling you the type, and it's giving you the definition of it and any information that goes along with it. It gives you everything that's required first, then it gives you everything that's optional that you can add on afterwards. So you see all of these different settings that you can set And you also see how they nest. So if I want to go into timeouts, for instance, this is like the Terraform timeouts. How long does it take to do this thing? I want to time out on create operations after 1 minute, 5 minutes, 10 minutes, etc. But the fact is, you have this information across the board for different Terraform services. So if you ever wonder, like, what actual commands can I offer? Reading the docs here, normally people will say, like, read the doc, or like, did you read the docs, is like a get you out of that person's face and, you know, put the onus on you. But here, actually reading the docs, the way that Terraform's language is structured, it gives you all of the available commands at your fingertips. They may not be as well defined, they may, you know, but they're going to at least have the name and the type, because they have to. That's just a part, like when you define the schema, you have to give it the name and the type. So again, that's me just waxing poetic about those docs. It's super important and something that I think is like really, really important. All right. So we've added our provider. We've added some resources. The next thing that we would want to do is take a drink of water because my throat's starting to get dry. Okay. And then after that, we're going to want to build our resources. So the first thing that we would do is we want to initialize our Terraform. And that's just saying, hey, Terraform, go get ready to do stuff. And that's going to create things like, it's going to basically find like, here's where all the files are. Here's the provider that I need. Here's all the providers that I need to download and install. And it's going to do all of that stuff. The next thing you do is what's called a plan. And a plan is it's going to run through your Terraform that you've written, and it's going to start trying to put the pieces together and figure out how everything connects. As I mentioned before, Terraform doesn't care about your structure. It actually will try to define that structure for you based on what the provider has offered. So if you have, you know, a bunch of things that are running, it will just try to spin them up. And then based on what the provider has specified, it may or may not try to spin them up in a particular order. That's up to the provider to determine. If you need to have them spin up in a particular order, I actually have one here that does need to be spun up in a particular order. You can add a value that's called depends on. And it's just, hey, for this resource depends on these other resources. And all that does is it just says, I'm going to wait for those resources to say that they're good to go before I start working on this one, this particular one. Once you've written out a plan, it's going to say everything's great. And then from there, you can apply that plan. It's going to run through it one more time, and it's going to say, are you sure you want to do this? You tell it yes. And then from there, it's going to start building out those resources. And if you want to tear all those same resources down, you would just use Terraform destroy. Again, it's going to look at your plan. It's going to go, are you sure? You type in yes. You have to type in yes. If you type in anything other than yes, it will not do it. Same thing with apply. And then it'll tear down all those resources. I'm going to live demo this just because I've done it so many times now that I'm not really afraid of it not working. Someone please say a prayer to the demo gods because I am absolutely testing them. Let's see. We're going to go into the Aiven console. We're going to go into my empty project here. There's no projects in here. We can see that there's no projects in here. That's great. I'm going to go back into my terminal. I'm going to go back out. We're in our Terraform spot here. I'm just going to show you all this Aiven.tf file here. Terraform required version. I modularized all of my services into one spot, so all I have to do is provide my API token, my project name, and my cloud name. That's all defined. We'll look at that in just a second. But we have one here. I'm going to run Terraform init. It's going to say, hey, we're looking for Aiven. We're looking for HashiCorp random. You already got those installed. They're within the version constraints that we need. Everything's good. Terraform's been initialized. We're ready to go. So the next thing that we're going to do is we're going to run Terraform plan. And you can see pretty quickly, I have some logging up here done because we were troubleshooting an issue. Ignore that logging. You normally wouldn't see it. And from here, you can see it says, oh, hey, you're going to resource this Kafka button app thing. Here's the ID for it. Here's the service name. Notice how it tells you that there's a service password and an admin here, but it doesn't give you the value. Like it's determined by the provider that, hey, that password is sensitive. We don't want to expose that in the plan, so that Jay, who is notorious for having to recycle keys during live streams, doesn't accidentally expose a password to a service that is running. We can also see that in this, we're building a Kafka topic. If you're familiar with Kafka, then Kafka uses these things called topics. We'll get to that in a second. It's called button presses, and we can go from there. Then we're going to do some other things. And a lot of this is just saying, like, you know, unless you've made equivalent changes, this is what's going to do things. And it's going to say, we're going to do the following things. We're going to create a bunch of stuff. We're going to create this ClickHouse service. We're going to use all these settings. Some of it, it'll even say, we don't even know what these settings are yet, but we're going to set them. And after we apply, we'll know what they are. Here's some sensitive values, but this is what's available to you. Then we're going to come in here and we're going to create these services, this Kafka and the Kafka button app. Then we're going to have this user configuration on it. Then we're going to create this Kafka connector. This allows us to connect to Postgres. Then we're going to create this schema, which is going to determine the data that we're getting for our application. And it's going to create that schema and put it in our Kafka schema registry called Carapace. And it's an Avro schema. There's a whole thing on that. Then we're going to create this button app topic. Then we're going to create this Postgres instance. And then we're going to integrate that ClickHouse integration into that Kafka integration. Like, do you start to see how, like, over time, if I had to remember to do all of these steps, set all of these fields correctly the first time, I could easily mess this up. But I don't have to worry about that because I'm going to just type in Terraform, apply. It's going to look at the plan one more time. It's going to go, do you want to do this? Only yes will be accepted. I hit yes. And it's going to start creating those services. I can immediately come over here. Let's give it a second. Boom. The services are now built and rebuilding. Like, I didn't have to refresh or anything like that. And it's going to take a second to rebuild. The one thing I will say about Terraform is that you still have to actively build all those things. So it's executing all of those steps. You're going to see this create, and do all of these steps through the process. It's not like a run, enter, and then it's done and you can immediately start using it. Like we still have to, we're doing what's called provisioning of resources. We still have to provision those resources. But we can come in here and we get some of that information already available to us. Not everything, but I mentioned there's a topic. We're not onto the topic yet. We're not onto the schema or the connectors yet. We're probably going to have to wait for those to build. Let's see, any integrations? Not yet. Where are we at? We are still creating the button app, the ClickHouse app, and the PG app, so we can see that as it's walking through. But the nice thing is knowing that I can just sit here, go get some coffee, get on my phone, relax and take a breather, and those services are going to run. Now, let's go back to our slides. If I made a change to any of that Terraform code, I wouldn't have to initialize it again, but I might want to plan. In fact, before you add a bunch of configuration changes, just run plan. And what that does is that validates that what you've written is just valid Terraform. Like, it's almost like I don't want to call it compiling because it's not compiling, but it's just verifying that what you're running is there. Now I'm just genuinely interested in where we are with this. Still creating. Okay, good. Take some time to do that. All right, so I talked about this a little bit as we were walking through some of that code. But as you saw, like one of the areas was a little bit busier than the others, and that was Kafka. Kafka had a lot of things going on. So Kafka actually has a lot of settings. And what I wanted to specify in this slide is that you actually have the ability to modify those settings here. You had that kind of basic stuff at the top, but you also have the ability to tap into more, all, none, whatever you're comfortable with in there. What this section of that Kafka resource is saying is, hey, Kafka user config, I want you to enable the Kafka REST API. I want you to enable Kafka Connect from that Kafka instance so that other tools can integrate with it. I want you to establish schema registry, and I want you to enable tiered storage. And all tiered storage is it allows you to take Kafka topics and move them into S3. We done yet with this? Still creating, 3 minutes in. These services take too long, in my opinion. Just want to see where we are in there. Okay, services are still unavailable. That's fine. But I want to go back over to the docs, and I want to show you the way that we knew about how to set this up. One, it was up here in our example usage. Let's pretend it wasn't. We could come in, what's required in our Kafka config for Terraform: the plan, the project, and the service name. The plan, the project, the service name. I'm actually surprised the cloud name. Oh, the cloud name, it'll pull whatever the default cloud is for the project, right? It doesn't say here. Cool. But when we looked at Kafka user config, right? So we could come through here. We could say, oh, Kafka user config, Kafka user configurable settings. Gives you a warning, hey, you can't reset some of these. That's fine. But we can see that nested schema. What is available in these user settings? I can just click on that nested schema, and now I see all of the settings that are available for that schema. So like Kafka Connect, should we enable it? We want that to be true. Do we want to provide a configuration for it? Yes, we do. What does that configuration look like? We can just click the link, and we can run through these individual settings that we want for that configuration schema. Or I'm sorry, for that Connect configuration. Now I'm just frustrated why this isn't done yet. Okay, ClickHouse is done. Postgres is done. So I can go back into my services here, and we see ClickHouse is running, Postgres is running. I can come into ClickHouse. I can see my service URI. I can see all the things that I set up. I don't think the integrations aren't set up yet because Kafka is rebalancing. If it's rebalancing, that means I can access it. But we can see up here, Kafka is enabled. Kafka REST API is enabled. Access route here, everything's good. If it wasn't enabled, you would not see this line here. Kafka Connect is enabled. If it wasn't, you wouldn't see it up here. And the schema registry is enabled. We can go to our schema. Schema's not built yet. Is the topic built? Topic's not built yet. Kafka is going to be the bane of my existence. But we'll come back and we'll visit some of this stuff later on when it's done. I'm not going to wait for it. But I am going to try to find my slides. Here we go. But you can set all of these settings. Let's see. Oh, tiered storage enabled. That's the one I wanted to check. Let's see. Tiered storage. Is tiered storage enabled? It's enabled. There's just no topic that's actively using it. So let's go back and carry on. All right. And we talked about that. So Terraform's terrific, right? Like, sorry, I had to throw the pun in because it's me. Terraform's terrific, right? Cool. This is like level 1. As we start to dive into this a little bit more, let's talk about this. Terraform is a resource provisioning tool. But what exactly does qualifies as a resource? This is where things get really fun, interesting, slightly confusing. Database services, things like Kafka, Postgres, Valkey, OpenSearch, ClickHouse, things like that. We've already seen that those are resources, right? Cool. That means I can use Terraform to create those resources. Okay, inside of those resources, I can configure settings like users. I can grant users access. I can select the disk size, the region, the cloud provider. All of those things are configurable via Terraform. We're still tracking on that. We can even do some simple things like creating a database within Terraform. We can say, hey, I want, instead of default DB in Postgres, I want to have Black Python Devs database as my database instance and create that within Terraform. Same thing with Kafka topics. I can create a Kafka topic using the configurations within Terraform. It might take a while because Kafka's slow, but like, hey, that's neither here nor there. I'm just mad that it's taking as long as it is to build that Kafka topic. Here's what you can't do. You can't provision too far down. I can't start creating Postgres tables with Terraform. It's a resource provisioning tool. It's not a resource. It's not your like code editor. I can't run SQL queries within my Terraform. I can't say, select star from users, blah, 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 blah. I can't execute those individual commands. You would still need to do those things. So you might have, again, we're talking about Python here. So you could, if you had a Django application, right? I think everybody here is kind of a relative fan of Django, but relative enough that you can kind of know what's going on. You could create your database, your Postgres database within whatever cloud provider you wanted. You could create the basic database that you want to connect to inside of your Django app. But what you couldn't do is tell it, hey, I want you to run Django, what is it? Django manage.py or manage.py migrate, to migrate your schema or migrate your tables, and or do like if you're using Fast API with Postgres, or you're using a Limbic, you can't do like a Limbic migrate. It's not going to do that part for you. You still need to do that. So you're still going to need to run your Django quick start, or I think it's quick start. You're still going to need to run those initial like code steps to get you off to the races. But the infrastructure around your application will be fully set up for you. And I would also argue you possibly don't want Terraform trying to do that stuff anyway. Imagine if you had like it initially populating terabytes of data. We've seen how long it takes to build a Kafka instance, right? So we don't want to do that. All right, here's the first break. Are there any questions so far on what we've talked about? I'm going to wait a second. I'm going to check Ghosty really quick. Everything's done. Ooh, I'm going to take this break. You could do some of that if you use Pulumi, since you could just write it all in Python. Yes. That is where Pulumi does differ. I would argue you probably don't want to do that in the same code that you're doing Pulumi things. Yeah, could and should are different pieces there. Because imagine if like if your Django setup is wrong, but your like infrastructure setup is right, and you get errors somewhere in the middle, and you're just like, did things get built or did they not get built? And then you have that whole issue. Let's go back to our console here. I'm going to refresh that. Yeah, there we go. All right, cool. So Kafka's running now. I said we also created a Kafka topic, right? Boom, there's our Kafka topic. So that's up and running now. I said we created a schema for Kafka, right? There's our schema. We defined what that schema was. I think I can actually I can actually come in and see that schema well defined. So we were able to set up our schema. We were able to create that version. If we came in and we changed this schema for any reason, it would just make a new version. It would say version 2 here. What else did we do? We created an integration with ClickHouse. So this is our ClickHouse instance. So we've managed that. And from here, we can go into our ClickHouse instance. We can see it created our Kafka database. It didn't create a table, it created our Kafka database. And we can see that we're getting our button presses from Kafka. All of this was configured for us, so we don't have to go in and manually do it every time. Let's see. And then there was one more thing. I'm trying to make sure that our Postgres. I don't think our Postgres thing has anything in here. No, because everything is managed through the Kafka connector. The Kafka connector. Yes. And then we set up this entire like JDBC connector to send all of our Kafka topics into Postgres. And we can actually go in and look at it. We actually configured that whole thing. We did all the configuration for it right then and there. Yes, there's a username and password there. I'm going to destroy this before we even get any further, so that's fine. And we'll keep it moving. And we did all of that with that one command. With that one Terraform apply. Now, let's say, even if I didn't make a change, if I wanted to run Terraform plan again, it's going to look at our schema. It's going to look at what's already set. It's going to sit here and pause for a second. Oh, it's refreshing the state on the button presses. That's always fun. Okay, cool. And it's going to tell us, hey, the code that you have, the Terraform that you have right now is no different than what your configuration is on the actual service. So you don't actually have to run apply. Now, if we change something, then it would go, hey, there's one change that needs to be made. And then we would go from there. I don't actually know what I would want to change, so I'm just going to not do that. And as I mentioned before, we can run Terraform destroy. I know for a fact we're going to get an error. And the reason that we're going to get an error, I will explain it. One of the things that we set on this topic was I don't see it in here. We told it that it has to be, it's protected so that you can't just delete it. And I will prove that by looking at modules, kafka.tf. Keep going down here. Termination protection is equal to true. So when I try to destroy this, it's going to delete everything instantly except for Kafka because it can't. It physically can't. So I want y'all to see, again, I'm going to go back to my project here, nothing up my sleeve. Terraform, destroy. I'm going to be cheeky and I'm going to just say auto apply, which is just, or sorry, what is it? Auto approve. Auto approve just means say yes for me. It's actually more keys than just typing yes when we get there, but I'm going to hit this button. I'm going to hit OK. We're going to wait a couple seconds. It's refreshing the state on that connector. You saw how long that took the last time. Boom, they're gone. Everything was destroyed. Kafka wasn't destroyed. We go, hey, why was Kafka not destroyed? And it tells us here, cannot delete Kafka topic when termination protection is enabled. There we go. So at that point, I then have to go in here and say, delete that service. No big deal. Cool. Kafka's gone. We're back to an empty project. And if I wanted to reapply those services afterwards, I could just do Terraform apply again, and it would reapply them all. And I could do this all day if I wanted, up and down, up and down, up and down. I might get a call from our SREs. They're like, what are you doing? But, you know, it's fun to keep them on their toes, I guess. All right. That was part 1. We ready for part 2? I mean, whether we're ready or not, we're going into it now. Part 2 is much faster. We're going to talk about data, variables, and locals. We've talked about data a little bit already. I just want to make sure that we understand kind of where we're going with some of these things. I highlighted the wrong thing here. It's supposed to be this one here. As you can see, we called this data. As I mentioned before, data is when you are grabbing information from your provider without the ability of changing it. So data is like getting information, whereas if I were to set a value, that would be saying, I want this value to be a thing. So here we say, hey, I want my data, I want the project data to be whatever this value is. I want it to be this project name. I want you to come in here and provide data on the Aiven project button app. And I'm saying here, data, Aiven project, button app project. I could ask for more information here. I could say, give me the default region. I could say, give me the creator of the project. I could say, give me the list of services in this project. I could get all that information, but what I couldn't do is I couldn't spin up and tear down resources within it. All I can do is say, hey, give me information about the project whose name is this variable that we set. And that's it. Again, I apologize. This is the wrong highlight. That's my fault. We could also use data in data, which is kind of its own little thing. We can say, hey, I want this random string to be 6 characters here. Again, we talked about this before. We did this resource. We grabbed this value. I think that's why I pulled it. That might be why I highlighted this, is that, hey, we got this random string suffix result. This is data that was provided from this random string resource that we have. But in this case, we created that. There we go. And the thing that I do like about this area, this random string suffix, is we create this one time. And with it being created the one time, for each instance, it doesn't change. So I don't have a random string for each of my services. I have a random string for each deployment, each unique deployment of my Terraform instances that I've created. So if I have 5 versions of this code running around, then each instance of that code will be different, but each of the services within them that get created will have the same random string suffix. And again, a lot of that is just for organization. Next, we have variables. So as you can see, we called this Aiven project name. Aiven project name has to be defined somewhere, right? So early when we looked at our tree, when we looked at our files, we had this file called variables.tf. Now, and yes, every time I see it, I immediately go variables default. Like what are we doing? Like, so I have to just get that out of my own like little habit. But we look at our variables.tf file, and then from in there, we've defined what this variable is. We're saying like, hey, this is our Aiven API token. This is the API token for the Aiven service, and it's a string. This is what we've defined, not what the provider is defining for us. So just like when they're telling us what they're expecting, we have to tell them what we're giving them. And it uses that to make sure that types are equivalent. Also, you might notice some of this space in here, this empty space, and how the equal signs are supposed to be lined up. That is a convention that it exists within like Terraform. It exists within Golang. I'm okay with it. I'm kind of either way with it. Some people like it, some people don't like it. It is a thing in Terraform. You don't have to do it. It's not going to break your code, but you will often see Terraform written that way, where the equal signs and the values are all spaced out. Now, I put the variable information in our variables.tf file. That's just one place to put it. That is a common standard of doing it. You can also define your variables within the Terraform files that you're working in. So I could put my variables for my Kafka app inside of my kafka.tf file. Ultimately, it depends on how complex your infrastructure is, on what you're going to want to do. For us, I really only set like 4 or 5 of these. Also, I apologize if y'all can hear like a lawnmower behind me. I did not know that they were going to be doing yard work today. But like I only set like 4 or 5 variables. So in that moment, it's like I don't need to have 4 variables across 7 files, especially when I know that those variables are going to get used across multiple files. I would rather just set it in one place and see all of those files in one place. I can definitely do that. Now, you may have noticed I still never defined what that API token is. I missed this part. You can also pass a default definition. So you can say, I want the default value of this to be a thing. That way you can override it if it's there and not override it if it's not there. If I wanted to tell you what that variable is, I would just say Terraform apply. By the way, the variable is Aiven API token equals ABC123. Now, writing it out for each of these would become a pain and kind of, you'd have to do it every single time. Nobody really wants to do that. Nobody's got time for that. So instead, what you can do is you can create what's called a terraform.tf vars. And this is just terraform.tf variables. And you can define all of those variables in a single file. And then you just run Terraform apply and it will read those files and go, cool, I got you. Let me apply all of those when I run it. And I was hoping I would get to this point. I thought I was going to get to it a little bit earlier. Terraform can also read environment variables. So if you want to just pass it in as an environment variable, which is what I usually do, because it makes it like, hey, if my code is already going to require some of this information, like if, I have a web app, my web app wants to talk to that same Postgres instance, I'm going to need the database name and all that stuff. Why don't I write it once as an environment variable and then I can just pass it in? And if I give it TF underscore, Terraform can then read it. My web app can also read it. I just need to know that it's set as that. So you can set environment variables. You just have to have TF underscore in front of it. There are also commands that you can apply with that TF underscore. As I mentioned before, I have logging enabled on my Terraform instance. the way that I did that was I used environment variable that is tf_log, and then I just set the debug level to a lower value than what is normally set. All right. Then you have these things called locals. Locals are basically like variables, but they exist locally on the file and they're only used within that file. So inside of my Kafka Connect Terraform file, I have a local called modified schema URL. And it is a Terraform function. Yes, Terraform does have functions. You can call them. And it is this ugly function that is replace. And basically it says, I want you to get the value of my schema registry URI. The bad news is I need to manipulate it a little bit. So what I want you to do is I want you to go and strip out the username and password from that value. And I need you to just replace all of that with just HTTPS. The reason I do that is because Aiven doesn't expose just the schema URI. It exposes the entire schema registry URI string that includes the username and password. In my Avro configuration, it doesn't want the username and password included in that. So instead of having to write this long thing out twice, I wrote it once, basically creating a local variable of it. And then I said, hey, the key converter schema registry URL is equal to my local modified schema URL. Same thing for the value converter schema registry URL. They're the same. So I can just write it one time and apply it across. And the last thing is in this section is output. Now, Terraform output is great because Terraform output gives you information back. When you're defining output, you can say, hey, I need the Kafka service name. I need to know what my service name is. I need to know what my service endpoint URI is. Can you give that back to me? And the way that you would retrieve it is, do I tell you? Terraform output. And what it would do is it would give me that value. It'll say, hey, your Kafka schema information is whatever. We talked about this a little bit earlier. You saw where when we did our Terraform plan, there were areas that were labeled as sensitive. And like you couldn't see them. They were like, hey, your service password, that's sensitive. My Postgres service URI, if I say, hey, give me that output and it's a sensitive output, it will not give it to me. It will actually tell me. It'll say, hey, you're trying to retrieve a sensitive value. You can still retrieve it, but they want you to just know that what you're asking for. So the way that you do it is, well, one, the way that you set a value is you put sensitive equals true. And then it'll know, because it won't even let you set the output unless you mark that, yes, I understand that this is a sensitive output. And then the way that you get it is you ask for the full JSON. And you say, hey, give me Terraform output, but give me the output as JSON. It'll give you that output, and it'll say, hey, this is sensitive, but the username is here, and the value of that is here. You can also do raw, which is Terraform output. I put dash JSON here. I think it's actually just dash JSON. If you do dash raw, you have to define what value you want. So here, the value we were looking for was Postgres service URI. I would have to do Terraform output dash raw, whatever service URI. And then it would give you just that value as it is. And it would just give you the raw value. And sometimes that's useful if you want to like pipe output specifically into like a .env file. So if I need to get a bunch of values for my database so that I can, feed that to my Django app or my Fast API application, you might want to do Terraform output dash raw Postgres endpoint service URI. And then, if you know that command, you can say echo, or you can just say that command and then do the little like greater than your .env file. And you could put that directly into your env file. Or you can do, echo, whatever this value is, equals the output of this command saved into your env file. Any questions before we go to the final stage? We are almost done. This is the shortest section, and it is also the one that is the most like mind-bending but useful. Nope. All right, in that case, we're going to dive right in. Modules. Modules are a lot. And in fact, I'm still learning about modules, so that's why I said it's the shortest. We're not going to go too far into it. Originally, this was that tree that we were talking about. We had our Terraform folder, we had our base Terraform file, and then we had all of our different resources all in this flat structure. And this is just your standard Terraform build that we were talking about here. When we look at modules, what we can then do is we can say, I want to make it so that a lot of what we're doing is standard, but I want to reference it and provide some subtle differences. Now with that, you would call a module the same way that you would call a provider. You would say, hey module, here's my module name. I'm giving it the name here. I'm saying this is Aiven services. And then I want the source to be this modules folder. And then your module is going to require some parameters, and you have to provide what those parameters are. You're going to say the API token is this variable, the project name is this variable, the cloud name is this variable. Those are all the things that were required of me from my setup. So now, instead of having to create all of these files every single time, I have this one module that I can just run, and I can run it as many times as I wanted. We talked about that before, right? So we could say, I haven't tried this, so if it doesn't work, I'm doing something slightly wrong. Let's see. If we go to Aiven.tf here, you can see I have this Aiven services module. Let's say we do here, we have Aiven services, dev. Great, we have that. And that's going to pull from there. We've already proven that we can run this because we've already run it. But now let's create another one, and we'll call it prod. And we can inherit from the same services. We can do the same thing. Our cloud name, we'll just change the cloud name here to be, let's mess with our friends up north. I know there's someone from Canada here, so we'll do Google US East 2, which is, oh, that's Ohio. Wait, which one's Montreal? Which one's Montreal? Do we not have, am I thinking of AWS? Well, we tried. Sorry, no love for Canada today. But our default, and can I show you that? Our default is GCP. It's Google US East 1. Our cloud name here is going to be AWS US East 1. Again, this may not work because I don't know how the random numbers are going, the random is going to apply. I'm hoping it does it correctly. If it doesn't, then we can mess with it a little bit. Module is not yet installed. Oh, see, and it tells you, hey, you're trying to do something you haven't done yet. Fix it. So I also do like Terraform's like errors because they're just like, do a thing. Cool. Hey, we did everything. You already had all this stuff. Let's run it. Let's run our plan. Notice how originally we had 8 resources and now we have 16. So Let's do Terraform apply, auto approve. It's going to start building. We got an error. It didn't like that. Oh, I guess I don't have access to AWS 1 US. But we can come here and we can look and we can see. Oh, it did work. It did do it right. So we have 2 different suffixes being created. Apparently, we can't use Postgres. I'm actually surprised. It's kind of funny that it's like you can't use AWS US East 1. Maybe we're overextended on that. But as you can see, like that can cause some issues down the road. But here you go. It's going to start creating those. And we now have 2 different versions of the same project running simultaneously. And the way that we were able to do that was we modularized our Terraform code so that we could call it as many times as we wanted. Now, originally I had emojis in here and the response there was kind of a shrug emoji like, all right, that's cool, I guess. Yeah. Oh yeah. Yeah, we just did that. Here's the thing. These modules can live anywhere. And I mean anywhere. So they don't have to live in your Terraform folder. They don't even have to live in your project. They can live in these broken links. Why are these links broken? Canva, what are you doing to me right now? No, I know you didn't. There we go. I don't know why those links broke. That was rude. But you could put this in your code. You could put these modules on GitHub in a different GitHub repo. You can put them in AWS and S3. You can put them in a Terraform registry like HashiCorp's Terraform. You can put them in a private environment that's run by HashiCorp that's called HCP. And you can manage a bunch of different modules that way. And then that way your team has access to these modules, but no one else does. They can live. These are just some of them. You can put them in Bitbucket. You can put them at random HTML or random HTTPS URLs. Like there's a lot, you can do a lot with this. And the way that you reference it is if it's in a GitHub repo, you just say github.com/Aiven Labs, Aiven Services for if that was a thing. This isn't a link yet. My team is actually working on creating a Terraform cookbook for all of our services. And the way that you'll access the resource that you want is you'll just go to Aiven Labs/TFCB for Terraform cookbook. And then you add 2 slashes and go into the folder inside of GitHub that you want it to pull from. And then it will be able to build from that place within GitHub. And that was the like clicking moment for me that was like, oh snap, I got to spend all day and write 60 slides on this. Because at that point, Terraform allows you to start creating your own environment for how you deploy projects. If your team has a way of, here's how we do all of our Django builds, then you can say, here's a module that defines our Django builds in Terraform. Do that. And you can sit that next to your Fast API builds. You can sit that next to your Flask builds. You can sit that next to your Next.js builds. You can sit that next to your RAG application builds. You can sit that next to your heavy data, like data churning, machine learning builds. You can start to build out your library of different infrastructure platforms. Now, again, once you start wanting to like proprietize that and things like that, you're going to start looking at different tools. Again, HCP is kind of the standard since it's built by HashiCorp, maintained by HashiCorp. But that gives you an opportunity to start developing your Terraform to serve not just you, but to serve your entire team, your company, your developer ecosystem, or whatever. Don't worry, I'm not signing anybody up for extra work here. I'm just saying it's possible. And that's it. That wraps it up. At this point, are there any questions? I've been going at this for an hour and a half, so I'm definitely happy to answer any questions if we have them. We got people typing, so I'm waiting for typing to go through. Are there any tips that you can suggest that a noob can use to avoid high costs when setting up resources? Yeah. So this is a thing that this was actually where the whole journey into Terraform started. Is Kafka is expensive. That's why a lot of people don't have a lot of experience with Kafka. Is that Kafka is just expensive. Like this setup that we have here, not with all of it running, with just the 3 services, that costs about $1,000 a month. So there is like an issue of how do I make sure that I set it to be the bare minimum of what I need. My biggest piece of advice would be take advantage of modules, because if you notice here, in my code, well, it's still creating stuff. Let me, pane, create, new pane. There we go. If I go here and resize this, I look at my Aiven.tf. I don't ever set the that's called, I don't even remember. It's called contexts. I don't actually set what cloud plan I want. That's actually done inside of, let's see, modules. That's inside of here. That's in up here, business 4. And we can see that here that Kafka should be running business 4. So when you're building these services out, if there are things that you don't want set or you don't want to be up for discussion and you want hard code them in the module. I can't change that value if I wanted to. So I can't come into my Aiven.tf in here and say like Kafka plan and then, business 16. There's no way for me to do that. So I would say figure out what is the minimum cost for what you're trying to accomplish and set those values specifically so that you have those things built into the module. That way they can't be overwritten. And if you want them to be able to be overwritten, the way that you would do that then is you would just set it as, you could say var plan. We probably want to call that like Kafka plan. And then delete that. Save that. And then inside of our modules variables, you do the same thing here. Just copy that. And then just do Kafka plan. and then you would set that as a string, and then you could set the default to something. I mean, again, you could still set it as business 4. But at least then what you've done is you've given it as a default, and then if someone wants to come in here, then they can say Kafka play. As you can see, like it even like the tool like auto corrected, like auto detected it and said, okay, if I want it to be business 16, I can set it to business 16, but I have to manually do that. That's the way that you would go about not foot gunning yourself into like getting the most expensive service out the gate. Cool. All right. Are there any other questions about Terraform or the presentation? Okay, I will not get off the camera until there is a question about Terraform or the other presentations. How about that? Y'all gonna force my hand here. Anybody? Everybody's like, oh no. That don't prevent y'all from leaving. Sandra, what's your question? And also, if y'all want to come off mute and just ask the question, just you got to do like the right click, raise your hand, ask to come on the stage. There you go. I think I gave you access to come onto the stage, Sandra. I think you gotta. I can't bring you onto the stage. I think you have to bring yourself on. But I did. There you go. And you're. Yep. Also, shout out to Sandra, who is our like community, one of our community liaisons. Does the hard work of welcoming everybody into our channel. We've almost got like 1,000 people now, and Sandra's like responsible for welcoming every single one of them. So, Sandra, I think your mic is not working. I don't know what it is. If you want to try to figure it out, let me know. You might have to. Discord does that sometimes. You have to like close Discord and reopen it. I'm gonna bring Olu on stage as well. What's up, Olu? I can. Hey, it's a European company, so as far as I'm concerned, like we're good. It's literally a button. I mean, if y'all want to play with the button app, I will share the button app with you. Here you go. Like, have fun. Click the button. It clicking the button does absolutely nothing. If you don't believe me, click the button. I mean, are you sure? Yeah, if you click. Now you're audible. We can hear you. Yes, clicking the. I love it. Very great. Did you have a question on the presentation? If I'm being honest, I kind of can't. Um, and the reason for that is a lot of the setup that I learned around, like, here's how I structure my infra code and all that stuff, that was based on the learnings that I got when I was at Microsoft and doing bicep. And like a lot of that stuff just translated over. And I'm not gonna lie, I did a lot of like, I'm going to try a thing, and then when it doesn't work, I'm gonna just read the error, I'm gonna try to fix it, and if I can't fix it, I'm gonna feed the error code into AI and go, what am I doing wrong? And then it's gonna give me some bad code, but at least it's gonna give me like something that doesn't look like what I have, and then I'm gonna like compare the two and figure out the happy medium. Yeah. The one thing that I will say that I think is beneficial is that the actual error messages that Terraform gives you, because Terraform is so strongly typed when it comes to like how providers, like what providers have to provide, it you can usually figure out like where the problem at least exists. It may not be like the exact answer on what to do, but like exact for here, it's not just telling me, oh, I couldn't build that Postgres app. Instead, what it's saying is like access to cloud service plan was denied. So then I'm like, all right, cool. Did I type it wrong? Or did is there like something else preventing me from going in and selecting that? Um, I actually don't like this error message in particular because I know what the problem is because I'm an Aiven employee. If someone else ran into this problem, one, we'd have a serious issue because this is like a over provisioning problem where like the org that I'm in only allows us to create so many services per region. And it's basically saying, hey, there's been too many services created in this region, pick a different one. But the other person may not know that. Um, in terms of just learning how Terraform works, I will say that like AI in general, because Terraform has been around long enough, AI does a relatively good job of diagnosing actual Terraform errors. And the Terraform error messages themselves are pretty good. That if you tell AI straight up, explain this to me as if I have never used Terraform in my life before, it will actually break it down to something that is reasonable. Again, the thing that it's going to mess up on is it doesn't know what your layout looks like. So it might give you values that just don't exist for that operator. And that's where I think you do have to kind of use a combination of like, okay, what is AI trying to tell me? Also, what do the docs say? And how do I use both of those tools side by side to get the value that I want? But I'm not the person that's going to tell you to just vibe code your way through it because that gives me a headache. But what I will say is that I've tried 3 different AI tools on Terraform, and all of them have at least given me something where I could go, this is what they're expecting. And actually, I can give you a perfect example of this. Inside of our modules, Kafka, is it Kafka Connect? Nope, wasn't this one, it was the other one. This one, yes. This ClickHouse Kafka user config, I had no clue what it was trying to get me to do because we have this columns field here, and this is like this is basically like JSON that's been deconstructed, and we had to convert it into Terraform code. And I had no clue how to do that. And I kept saying, I'm using Avro, I'm using Terraform. I need to define these columns. What do I do? And it told me to write it out like this. And I was like, you're smoking crack. I don't know a lot. I know that is not how you do it. This looks wrong. I'm like looking, I'm like, why would I redefine columns 8 times? Like that doesn't make sense logically in my head. And I could not get it to work. And I said, you know what? I'm gonna go with what AI said. It came up, it worked the first time, and I'm sitting here looking stupid. So I'm like, you know what? I was like, my bad. I did not recognize your game. Like let me just go back and figure, like let me go back and reevaluate my life. But I did also then file an issue to our team and say like, we should name this better. We should do something different here. I don't like this. And they just said, be quiet. And I was like, all right. But yeah, like I would say like you can at least trust that AI is going to give you valid Terraform. The thing that it may not give you is the correct parameters. Like it may not give you the correct name. It kept wanting to give me like, instead of like group name, it kept saying group. And I'm like, it's not group, it's group name. I know it's group name because I can go into the Terraform page here, go into the ClickHouse configuration. If I know how to spell ClickHouse. Oh, nope. It's, what am I looking for? I'm looking for Aiven integration. Aiven service integration. I know from there I can find ClickHouse Kafka. Where are we at? ClickHouse Kafka right there. So then I can go ClickHouse Kafka user config from here. And I can see group name right here. Group name, not group name. And again, this is available for all of the resources, all of the Terraform modules, because Terraform forces you to build the docs based off of the schema that's defined in your Terraform code when you're a provider. So you can quickly fact check Terraform that way. But yeah, in terms of beginners resources, I couldn't find any good ones either, cause yeah, that's annoying. You're welcome. Nick, I'm gonna invite you to the stage while I'm answering your question. All right. Are you able to configure custom domains for apps via Terraform? Yeah, you should be able to. You should be able to. The problem that you're going to run into here is that, like, what service are you using? If you're using Microsoft, let's see, what is it? Azure domain, I don't know, some Azure thing. It's gonna be determined by whatever provider you have. I'm trying to think of a good one, honestly. HashiCorp Google, interesting. Lifecycle management in Google, API Hub, API Gateway config. Is there a domain in here somewhere? Display labels, gateway config. I don't know if I'm going down the right path here, but yeah, you're gonna have to check the individual docs of whatever Terraform provider you need to use. I hope that answers your question. I can't hear you, Nick. You're muted, so your mic may not be enabled. All right, y'all. Any more questions? If not, thank you so much for hanging out. Y'all do Doreen a favor. If y'all got a topic that y'all want to talk about, you don't have to talk about it for 2 hours like I did. You can give a 5-minute talk. That is perfectly fine. Oh, Monica had a question. What's up, Monica? I'm looking forward to PyCon Kenya. Cool, cool, cool. Absolutely. Good. What's up? What's your question? Yeah. I mean, the harsh reality is that like I love writing Python code. I've written more Python code in the last month than I wrote almost all of last year. I spent the last quarter writing Go. And now I'm moving into a management position where I don't get to write a lot of Python code there. But when I do get to write it, it's usually supporting things like Terraform or building test suites or load testing with things like locusts, and building Docker containers and all that gnarly stuff. Like being a developer, especially being a professional developer, often requires you to learn about different tools, and Cypress is one of those tools. Now, I'm more of a playwright person myself, but I'm not going to come in and tell people that they should choose one or the other. I think they should be presented with all of the options and then make those decisions for themselves and what's going to be best for them in their career. So I definitely support the idea of coming in and maybe giving a workshop around Cypress. I'd be interested because I haven't played with Cypress all that much. So I mean, you've got my vote for a topic, but do me a favor, make sure you put that in general so that or message like ping Doreen, who Doreen is going to be actually in charge of the meetups going forward. Ping Doreen either in general or in one of the other channels and go, I have this topic that I would like to give a workshop on, and I'll do that. All right. Perfect. All right. I see Jorge just showed up. Oh, Jorge, we're literally taking questions at the end and wrapping up. It's good to see you though. Jorge is a mentor of mine, and one of the folks that really helped me to learn, was helping me a lot in my Let's Learn Python journey. Um, and also does QA stuff. What's that? Okay, well, shout out. In this case, I'm going to shamelessly plug the San Diego Python Discord. I'm sure they are always looking for more people to get in, to join there. Um, and they do meetups. They do a hangout every Saturday where people can come and ask questions. I don't know how often Jorge's in those, but uh, definitely definitely a long term friend. Come on up, Jorge. What's up? It is. It's in Discord. Links in the chat. The one downside I will give for our folks who are in Africa, uh, they're on West Coast timing, so I I think the same applies. My Ca- s- yeah. So yeah, you're 7 8 hours difference on that one. Um, oh, 9 hours. I think it's the same time, but it's every Saturday, except for like holidays and stuff. So occasionally I will pop in. All right, cool. Absolutely. At some point, we got to get you in here to do some testing, a testing workshop. Awesome. All right, y'all. That's gonna wrap it up here. I'm gonna stop my recording.